Good evening, folks. It's Monday, January 8th, and tonight is the first class of Global Cooling 101. I am your host, Diamond. My background is in paleoclimatology, specifically orbital perturbations as they relate to the Milankovitch orbital cyclicity. In layman's terms, I studied celestial mechanics as it relates to the ancient climates on Earth. Now, what I'm showing you here in our introductory class is a correlation between yearly average sunspot numbers and the Central England temperature graph. Now, the top graph with the red line is 1659 to present. And you can see represented in light blue and pink the Maunder Minimum and the Dalton Minimum as they have been laid out in our historical record. In central England, there was a very cold period during the Maunder Minimum here, right before 1700, probably from 1680 to 1700, and then a very cold period during the Dalton Minimum, maybe 1810 to 1820. These extremely cold periods happened after a lag in solar activity. So as the sun's activity waned towards 1650, so did the temperature in central England. And as it stayed at a minimum for over 30 or 40 years, the temperature continued to drop. And here in the Dalton Minimum, in 1780, the sun shut down. And shortly thereafter, the temperatures dropped in 1800, here at the minimum. And they stayed low for the whole Dalton Minimum of low sun activity. And they started rising in 1810 again when the sun started gaining activity. Again, the Centennial Minimum. In 1870, the temperatures began to drop as solar activity waned. So what we can clearly see from this graph, again here, as in just this cycle 20, there was a dip. And you can see here the drop-off during the predicted eddy minimum, the current minimum, and I've added the blue line as the prediction to take us below any of these points. And that's just in 2 decades, bringing us back here to the 1700s. Now, I specialize in Milankovitch. We'll talk about that in a different episode. These are longer term cycles. The 26,000 year precessional cycle, the 40,000 year obliquity, the 100,000 year eccentricity, which you can clearly see here in the Vostok ice core and the benthic forams. We'll talk about all these things and unravel them as we move forward. But as a primer, we need to learn about solar cycles because the sun controls climate. Solar cycles happen at regular intervals between 10 and 11 years. And it's the flipping of the poles on the sun. The North Pole flips south and south goes north. Positive and negative, up and down. It's an 11-year cycle, 10 to 11 years. And it consists of a maximum and a minimum. And during solar maximum, the sun is brightest and has the most activity, the most flaring. And during a minimum, it goes quiet. And these maximum and minimums are packaged into packages where you have a solar maximum grouping and a solar minimum grouping. The maximum grouping, solar max here, 8, 9, 10, 11, and a minimum, 12, 13, 14. Max, 8, 9, 10, 11, minimum, 12, 13, 14. Max, 17, 18, 19, global warming, 2020, global cooling, boom, quickly, where we are now. These solar cycles, a lot of activity and a lot of study has happened in the last few decades. And we have lots of information from cosmology and plasma physicists and people looking at the sun. There's lots of information, lots of papers. There is endless amounts of work. And a good place to start is with suspicious observers. If you're not subscribed to the page, I'll leave you links down below. There's 1/3 people that are subscribed currently. We'll be at the Observing the Frontier conference in February. We'll be reporting on that. If you're an observer, it's the place to be. It's where the only real science is currently happening. It is unhindered by the mainstream. You know, crony capitalism and all that. Now, when you come to Suspicious Observers on YouTube, you want to go down here and learn about space weather and the sun series. And this will get you familiar with the solar cycle and the sun. You need to learn how to view the sun to understand all of this science. Now, what's going on with the snow covering North Algeria desert for the 2nd year in a row? What is going on there? Well, if we come over here to NASA, they have wonderfully made this paleogeographic reconstruction for us, which shows us the temperature change for a 100-year period during the Maunder Minimum. Now, the impact of a solar grand minimum, because that's what we are predicting, the eddy minimum, which is a grand minimum we're going into in the next few decades. The impact of a solar minimum is clear when you look at this image, is it not? Where you can see that most of the northern hemisphere is 7 degrees, 2 to 7 degrees colder than normal. It shows the temperature difference between 1680, a year at the center of the Maunder Minimum, and 1780, a year of normal solar activity, as calculated by the General Circulation Model. Now, the deep blue across eastern and central North America and northern Eurasia illustrates where the drop in temperatures was the greatest during this period. And using your noggin, we're going into a similar period for the next 30 years. Nearly all other land areas were also cooler in 1680, as indicated by the varying shades of blue. The few regions that appear to have been warmer in 1680 are Alaska and the eastern Pacific Ocean on the left, the North Atlantic Ocean south of Greenland, and north of Iceland, Svalbard. So this is probably going to be repeated as we move forward. If we come down here, you're going to get links to all this. If the energy from the sun decreased only slightly, why did temperatures drop so severely? Well, because there's something else going on. The change to the planetary waves kicked the North Atlantic Oscillation, the balance between the permanent low-pressure system near Greenland and the permanent high-pressure system to its south, into a negative phase. When the NAO is negative, both pressure systems are relatively weak. Under these conditions, winter storms crossing the Atlantic generally head eastward towards Europe, which experiences a more severe winter. When the NAO is positive, winter storms track further north, making winters in Europe milder. The model results shown above illustrate that the NAO is more negative on average during the Maunder Minimum, and probably so during the upcoming eddy minimum, and Europe will remain unusually cold. These results match the paleoclimate record, which include tree rings, sediment cores, including foraminifera, and other data that is very high resolution from the GISP-2. And the snow in Algeria is right in this dark blue zone, right where the arrow is. It's predicted. We've all been predicting this. These are pictures from the last minimum. Now, as we came out of the mini ice age till now, the reason they've been able to sell global warming so easily is because that when you come out of a glacial advance, the glaciers recede. It's very easy to show that glaciers are shrinking. But that stopped because global cooling occurs during times of few sunspots, and we're about to go into a record sunspot minimum called the eddy minimum. Already there are no sunspots at the minimum of cycle 24, when we have at least predicted recently by the solar community 2 years of potentially 0 sunspots. Maybe 3, which will be the first time in modern history that that has ever occurred. And the last time that that occurred, glaciers advanced. We have glacial advances in the 1800s, in the mid-1800s, even in the 1950s. But especially in the 1680s and the 1520s during the Sporer minimum. There's so much to learn. I'm going to leave you with a treasure trove of information. Here are the Central England temperatures and thousands of other pages of information which you can go through on the Maunder and Dalton sunspot minima. We'll get to that. Now, you might have seen some articles coming out on the ocean floor sinking under the weight of melting glaciers. I'm going to link you to the paper, Ocean Bottom Deformation Due to Present-Day Mass Redistribution and Its Impact on Sea Level Observations. Now, I believe that this is nonsense, and it's to explain why sea level is dropping. They're talking about this catastrophic sea level rise, but according to the satellite data, for the last 3 years, sea level has stopped rising since the mini ice age and has turned a corner. I wonder why that's happened. I wonder why we've turned a corner. Is something happening that could possibly be driving the climate that's not man? Could it be that the paleoclimatologists like myself have been correct all along, and why these high correlations exist is because small changes in our sun, which is billions of times larger than our planet and in a very close proximity, could affect the global climate? Please don't argue. There's no need to pay your carbon tax. Here's a clear evidence right here. This is the GISP2 graph of temperature for the last 11,000 years. You can see all the major minimums. The empires swelling here. This is the Minoan warm, the Roman warm, the medieval warm, our current warm. You can see how much the mainstream is lying about how hot it is. It has been much hotter in the last 3,000 years. Much warmer. And we are dropping off the cliff and about to turn into a straight down pattern. You could see the CO2 concentrations below. A couple things I want to point out. That the peaks of temperature are followed by the peaks in CO2 500 years later. We've already pointed this out. Here's a peak, the Roman warm, the CO2 peak 500 years later. Here's the peak of the medieval warm, and here's the CO2 peak 300 years later. Peak temperature in 8,000, peak CO2 7,000, 1,000 years later. CO2 has nothing to do with changing temperature. CO2 follows the temperature. Don't believe the hype. It's nonsense. Guys, I'm going to leave you 350 non-global warming graphs from the mainstream. Now, this is very important because these 350 graphs each are from everywhere in the world. So if you want to know what's going to happen in West Central Sweden on the upcoming minimum, you just go to your associated graph. And here at 1800 during the Dalton minimum, you can see West Central Sweden was the coldest it has ever been in the last several thousand years. And here during the Maunder Minimum, the same. So west central Sweden is not going to bode well in the upcoming eddy minimum, based on paleoclimatological data. So this is Western Mediterranean, the Spanish Pyrenees. Here's the Northern Hemisphere temperatures. And what we can clearly see here is that the Northern Hemisphere is greatest affected. I've looked at all these graphs. During the Maunder and the Dalton minimums, the Northern Hemisphere suffers the greatest. It averages a 0.3 degrees C temperature drop everywhere. And there's massive fluctuations on a decadal scale being driven by the AMO and the PDO. These are 30 to 60 year fluctuations that wreak havoc during the cooling. There are tons of graphs here for you to peruse. We don't have time. There are 350 of them for every area on the planet. So if you're really doing your own homework and you really care about what's happening, you should look at these graphs. Poland, you don't suffer that much. Labrador, you're screwed. The Western Himalayas, this is all recent data. Let me just give you some more juicy stuff here. We'll quick look and get some more historic data here. Turkey. Turkey had a spike down during the centennial minimum. The central US, that's modern. Florida, there will be snow. You get the picture. Do your own homework. I'll leave you links to this graph, the fall of the Tang Dynasty, the Maya civilization. This is the northern warming. You could see the grand solar minimums taking out dynasties. You could see how the northern hemisphere is affected. Here is the Dalton minimum down spike. This spike right here. Boom, boom, boom. Here's the mini ice age. Here, here, and here. Here are the other grand minimums. And you can see the alpine glaciers waxing and waning. You can see how much glacial growth there was here in 1300. Which, if we come here to grand solar minimum and maxima, was the Wolf minimum. So get familiar with these graphs and what they're telling you. There's so much information to go through. Let's get to some of our, let's get to our experiment in Denmark with Heinrich Butenhuis. If you're not subscribing to his channel, you need to do so now and get this up to 1,000 so he can make a few dollars over there in Denmark. Please do that for us and to the community. He's taking his own time to do this experiment, and I'm helping him out here. He's telling you what he's using, and I'm going to source it for you on Amazon in North America and Europe. There's lots of options. The Taotronics LED grow light is $19, and it gets a very high rating. It only draws 12 watts. It puts out full spectrum. You just need a few of these babies, and they last for 50,000 hours. They have a very long life. Now, when you're looking around, you might find a cheaper version for about $7 or $8, but they suck. Don't buy this piece of crap. It's going to fizzle out. The Taotronics is what you want. The Swift Trans is not what you want. If you want to spend a couple more dollars, I suggest you get the UFO hanger. And this is only for $26. And you can grow a lot of herbs and vegetables underneath of this thing. Plus, it's totally trippy. It's totally awesome. Fully recommended by the Oppenheimer Ranch Project and Amazon. It's not that expensive. It has free shipping. You get 4 of these for $100, and you could be growing food for your entire family once you learn how to sprout. Now, guys, we are on Steam It, and we have a blog. Any of you guys in the Steam It atmosphere, give us support there. We're solar shut down. And we've put a lot of time into this, and we have very little return. We're also on DTube. There'll be links in the description. And I've put up 1,000 videos on DTube, and we've made $22. So give us support on DTube and Steam it if you're in those interwebs. And that's a heads up. And let's talk about some other things we need to talk about. We need to spread the community. And if you're looking for information, you need to be looking for it in the right place. And they've been coming here. We got 1,000 subscribers, guys, in the last 8 days. We hit 10,000 on New Year's. 8 days later, we had 11,000 subs, and we're almost at 2 million views. So the word is out. People are looking for information, and the graphs are going straight up. Look at the views. Look at the watch time. People want to know. So let's spread the love, and let's spread the information. If you haven't subscribed to the Radical Gardener, there'll be links to her below. She's from Detroit. She's new to our community. We're going to blow her up. She's got a Patreon page. She absolutely has an amazing point of view from the feminine aspect, and you better subscribe and watch all her videos. Also, the Ice Age Farmer, good friend of mine, we talk all the time. You know, we've been going through this for a while, and give him support because he has a point of view that everyone needs to hear. Adapt 2030 has been doing this for at least 3.5 years. We met through YouTube and the internet about 3 years ago when I was just starting Solar Shutdown. So if you haven't subscribed to Adapt 2030, he's got a lot of good things to say, and that's a boom. He's on the other side of the globe in Myanmar. This is a lot of information tonight. The sun is controlling the climate in a series of oscillating waves. There is so much cosmogenic forcing. It's so difficult to even begin. It takes decades to even comprehend the layers of cosmic forcing. It starts with the sun. And then our globe is wobbling, and our solar system has particular celestial mechanics that accentuates all of the forces of our sun. This results into very high resolution information that we have from the data on the planet, that we can look at the paleo record of climate. And now, with new technology and spectral analysis, can predict the future. And the future is colder. And that's a boom. And here's when Al Gore won the Nobel Prize and the global temperature data. And here's where our temperature is now. And you can see that there's 3 different scales of temperature drop depending on where you start the calculation. And that's a boom. And sunspots and total solar irradiance are directly related. So we're back here in the centennial minimum, and here we're falling off into the Dalton minimum. It's related to the output of the sun. As the output of the sun changes, the amount of sunspots change. And we are in a zero output period, which is going to drop total solar irradiance below 1360.5 watts per meter squared for the first time in modern history, in your lifetime. There's so much to learn. Let's do it together. We could survive and thrive in the future if we start preparing and planning now. The time to start preparing is now. Proper prior planning prevents piss poor performance in a grand solar minimum. And that's where we are. And that is a boom.